Watch this. A 5-volt line negotiates everything before 400 volts ever touches the cable. No sparks, no guesswork, no live metal in your hand. The plug talks first, then it pushes. Here is exactly how it works. Here is the danger. A DC fast charger can push hundreds of amps at 400 volts through a connector you hold in your bare hand. Energize that at the wrong instant and it can kill you. So the whole point of the handshake is this. The power stays dead until the plug is locked, verified, and both sides agree it is safe. Talk first, push second. That rule is the master switch behind everything else. Start with one pin called the control pilot. Think of it as a dedicated phone line running the length of the cable. The charger holds a steady 12 volts on that line, then chops it into a fast square wave on-off about 1,000 times a second. That square wave is the conversation. Now the car talks back, and it does it in the simplest way possible. It drops the voltage. Plug not ins. The line sits at 12 volts. Plug seated but idle. The car switches in a resistor that pulls the line down to 9 volts. Ready to charge. It pulls harder down to 6 volts. Actually pulling power. Down to 3 volts. 4 voltage steps, 4 states, no complicated code needed. Break time equals 0, 6 is / here is the clever part. The width of that square wave carries a number. A wider on pulse means more current is available. A narrower one means less. The charger literally shapes the pulse to say you may draw up to 32 amps, or up to 16. The car reads the shape and obeys the sailing. So one thin wire does 2 jobs at once. The voltage says which state we are in. The pulse shape says how much current is on offer. And notice what has not happened yet. Nobody has moved a single high-voltage electron. This is all 5-volt small talk. But small talk only proves the 2 boxes can talk. It does not prove the plug is actually plugged in, or that the cable can even survive the current. So how does the car know the plug is really seated and that the wire will not melt? That covers the talking. Now the touching. A second pin does one job. Prove the plug is physically home. It is called the proximity pilot, and it is beautifully dumb. The moment the connector clicks into the port, this pin completes a little circuit. The car sees it and knows, with no software involved, that metal is seated in metal. On a regular EVSE cable, that same pin is smarter than it looks. Built into the plug is a single resistor, and its value is a code. A low resistance means this is a fat cable, good for lots of current. A high one means this is a thin cable, go easy. The car reads that resistor and refuses to pull more than the wire can safely carry, even if the charger offers more. The cable itself vetoes the deal. Break time equals 0, 6 is / but a seated plug you can still yank out. And yanking a connector while hundreds of amps are flowing would draw an arc like a tiny welding torch. So there is a third piece. A lock. Inside the port sits a small solenoid and electric bolt. Once the handshake is underway, it drives a pin across the connector and physically traps it. You can pull all you want. It will not budge. The plug is now committed. So think about where we are. The 2 boxes are talking. The plug is proven seated. The cable has declared its limit. The connector is bolted in place. Every safety condition on the low voltage side is now green. And only now does the really dangerous question come up. Can we actually let 400 volts loose? Here is where it escalates. For a slow EVSE charge, those simple voltage tricks are enough. But fast DC charging needs a real negotiation, because the car, not the charger, is in charge of its own battery. So both sides upgrade the conversation. They keep using the same pilot wire, but now they send full digital data over it. Like squeezing an internet connection down the phone line that was only carrying beeps a second ago. This richer protocol has a name you may see. ISO 15118. The car introduces itself and states exactly what its battery wants right now. A target voltage and a maximum current, updated moment by moment as the pack fills. But agreeing on a number is not the same as being safe. Before a single high-voltage electron moves, the charger runs a check on the 2 thick DC wires. It briefly probes them to make sure the insulation is intact and nothing is leaking to the car's metal body. If that isolation test fails, the whole session stops cold. Right here, power still dead. Break time equals 0, 6 is / only when 3 things are all true. Plug locked, insulation clean, both computers agreeing on the set point. Does the charger throw its big internal switches, the contactors? Those are the heavy relays that finally bridge the battery to the cable. They snap closed, and 400 volts is real at last, current ramping smoothly up to the exact number the car asked for. Notice the order one more time. Talk, prove, lock, test, then power. The dangerous step is always last, and it never happens until every cheap, safe check has already passed. So what does that full sequence actually look like, start to finish? So run the whole dance top to bottom. You push the plug in. The proximity pin fires. Seated. The control pilot voltage drops through its steps, and the pulse shape hands over a current ceiling. We are talking, and here is your limit. The solenoid drives home. Locked. For DC, the two sides switch to digital and settle on a target voltage. The charger probes the big wires for leaks. Insulation climb. And only then do the contactors slam shut and let 400 volts pour into the cable, climbing to the agreed number. Every one of those gates ran on that thin 5-volt line. That is the answer to the whole puzzle. The reason 400 volts is safe, sequenced, and stoppable is that a tiny conversation had to finish first. And it runs in reverse just as carefully. Ask to stop and the current ramps down to 0 before anything opens. The contactors part while the line is already dead. The lock only releases after that. So the plug is never live when it is loose, and never loose when it is live. So the one thing to carry away. Negotiation always comes before power. The plug talks, locks, and tests before a single dangerous volt moves. Next time, we open the box on what happens when that flow runs backward. Your car feeding the house during a blackout. And why the plug on the newest cars looks nothing like the old one. Subscribe and we will explain it.